Alright guys, welcome back. So we're gonna move ahead and do some more cool stuff with these guys. Let me load from disk. And one of the things I'm thinking about is those trails. They might be okay actually, they're pretty dense I guess. And they're good enough. I'm not sure yet, but maybe we can do some, you know, testing before we actually say this is okay. One of the things I want to go ahead and define is the attribute wrangle. I want to define a few things before I convert it into a volume. One of the things I want to define is the point scale, the size of the particles, which will define the size of the volume generated. So I'm gonna say f at p scale, right? That's gonna be equals to the size. So the size will go from bigger to smaller, right? So I'm gonna use 1 minus at nh as normalized h. So now their size will go from bigger to smaller, and that's just gonna be an index. I'm gonna multiply this or time this with a multiplier, right? A channel called point size. Okay. Let's go ahead and click that plus button. I'm gonna change that to 1 for now, maybe 0.1 because the default setting is actually pretty big for our conversion. So that's the p scale, and also I'm gonna also use the same way to define the density. Let's make the density equals to the p scale for now. So again, the density gets weaker when time gets bigger. When their age are getting bigger. So we can also time this with something. Right? So p scale times channel density. Right, I'm gonna click the plus button again and grab the density up to 1 for now. Now we have those two crucial attributes to define how the conversion would look like. So I'm going to go ahead and do the conversion. One of the things you can use is fluid source. So let's try that. Okay, and before you turn that on, make sure that you save the file. So I'm going to save mine right away. Alright, and then I'm going to go for the display render for this guy. Alright, not really seeing anything. It's because we're using from the geometry. Now we don't have any surface, so we need to actually do this standpoint. Okay, that's gonna convert those guys into volume. If it's easier to see, we can press the D button in the viewport, change the background to a dark background so we can really see the volume being generated. Alright. Now I will say the density can be a little bit higher. I'm not really seeing anything. Let me actually visualize it with 3 and take a look. Back to 1. So here I can define the density right here. So instead of 1, I'm gonna change that to 3. As you can see, it actually recalculates. And I'm gonna also go ahead and I think I'm happy with the p scale. Maybe I can let's see. Still feels like we're not really seeing a lot, but those are just emitters, so I guess it could be okay eventually. And they might be, when I look at them now, I think they might be like too much of this area is going to be too overwhelming. So a few changes I want to make then. So I'm going to go ahead and shake this off instead of updating it all the time. Here, let's take a look. Our particle is probably too much over here and they're too spread out. So here in the pop network, I'm going to tell it to not vary that much on the variance here, maybe just 0.02, 0.02, 0.02, so that they're just following the trail and not really do too much. Okay, I can make those variations later on. So Alright, back to here. I can then recache this guy. Right? So save to disk one more time. Oh, it's pretty fast this time. Try that again. It's done right away. And yeah, let's take a look. And I don't really need to do anything on this attribute record, so let's connect that to the fluid source and take a look at it. I should get tighter result, which is probably what I want. Alright, so let's see, I kind of want to have a little bit more density, so here I'm gonna say maybe 3 times more than it's, so I can really see something. Well, I can eliminate those guys if they're too much. Now one little trick here is that the quality, right? The quality is defined here underneath fluid source. The division size 0.1 is probably okay, but 0.05 would be better. I can also give you tighter result. Okay. Just be aware that this could be very expensive, so you don't want it to go too crazy. Okay. Right. Now one thing you want to be able to see is the good trail, but it's not always guaranteed, especially those guys that are flying too fast. But it could be okay too, because those are the guys that are going too far away. At the previous 9 frame, right, they're just going too far away. I don't think it's really important to maintain a clear trail for them. Right. So let's say maybe P scale can be just a little bit smaller. 0.05 instead. Just as you can see now, the P scale really controls how the size looks like. Alright. So let's say this is cool. Let's take a look at our velocity volume. Our velocity is now looking like this. Now this is not out of the velocity, it's just one of the slice of it. So let's see. Underneath the visualization, we can change the position of that plane to reposition maybe here, right? That's actually where the velocity is. And you can see they're pretty generic. We can also give them some random initial velocity just to make things a little bit more interesting. That's going to be underneath the core noise. I'm going to turn that on. Okay. Now this is going to take a lot of time to calculate, because we're basically filling in velocity on this entire volume with the noise. And this volume is not small at all. It's a huge volume. So you have to wait for it to calculate. Alright, it is done. As you can see, that's a huge volume, right? So probably don't need that much, but I guess there's no easy way to really tell it not to, because it's based on the entire volume. So let's see. I'm gonna tell it to, let me save it in case it crashes. I'm gonna maybe just lower down the scale, right, to not make it too strong. So maybe instead of 1, I'm gonna go for 0.3, so it's like only 30% of the original strings. This is gonna take again a lot of time to do iterations, so this is just one of the ways you can do that, and it's probably too slow sometimes, and for the velocity field especially. Alright, but let's just wait for this guy to go through, and then we can talk about other possibilities that we can actually make this faster. But for now, yeah, this is really slow. Alright, now it's done. You can see it's much weaker, which is probably what I want. We want to make the size too, but I think the size is okay, because considering the size of our building, right, it's not very small. even it looks small from a distance, right? So I'm gonna say this is cool. So let's actually cache it. I'm gonna leave it for. I'm gonna call this guy pyro source cache. Right. And again, I'm gonna save my file and start caching it. Again, delete that heap name. It's really not what you want, because sometimes when you save the file with a different name, it will not be able to read it anymore. So just get rid of that heap name. And yeah, we're happy with that. So I'm gonna hit save to disk. And this may take again a lot of time to cache. Not sure how long, so I'm gonna stop this tutorial right now, and in the next one, when I'm done with caching, then we can maybe take a look at what do we do with what other options we can do with it. But for now, let's just use fluid source. Okay, thanks for watching. See you next time.